Welcome back to our intermediate algebra class. Today we will cover section 7.2, rational exponents. But before, try to work on the challenge. You can move only two matches to find a greater number than 508. The number needs to be greater than 508. And the difference today is there's no right, there's no wrong answer. The greatest number that we find will win. If a student find a number, another student find a greater number, that's going to be the winner. All right, think about your numbers, and in the meanwhile, let's work on our section 7.2. First, let's understand the meaning of the base a to the power of 1 over n. And basically, we will go over some definitions today. A to the power of 1 over n is the same thing we can rewrite as the nth root of a. And let's have a look at some examples so we can understand. If you have rational power, rational exponents, 81 is the base, to the power of 1 over 4. You can rewrite this as the fourth root of 81. Okay, and the fourth root of 81, we can find fourth root of 81, a number that multiplies by itself again, in total 4 times is equals to 81. Let's try 3 times 3, 9 times 3, 27 times 3, 81. Yes, so fourth root of 81 equals 3. Letter B, 64 to the power of 1 over 3. We can rewrite as cube root of 64. You can type in a calculator. 4 times 4, 16 times 4, 64. And what about letter C? X to the power 1 over 4. We can rewrite as fourth root of x. We don't know the value of x, so that's the answer. More examples. Let's say we have negative 16 to the power of 1 over 2. Look, we don't have parentheses here. That means only 16, only the number 16, not the sign, is submitted to the power 1 over 2. Okay, we can rewrite this as, so the negative is not to the power 1 over 2, only 16. Index 2, that's square root of 16, and we know that square root of 16 is 4, but we have this negative 4. Letter E. Inside the parentheses now, 32 times x to the power of 10. And this whole thing to the power of 1 over 5. Look, now we will apply a property of exponents. This 1 over 5 will be applied as an exponent to 32, 1 over 5, and will be applied to x to the power of 10. Let's write right now like this, 1 over 5. And there's another property of exponents, the rule that we're going to use, that if you have a number to a power, to another power, you can multiply those two powers here. This is equals to the fifth root of 32 times x to the power of 10 times 1 over 5. What's 10 times 1 over 5? 10 times 1, 10, divided by 5, 2. So that's equals to, oh, wait a minute. I know the fifth root of 32. You can type in a calculator, but I think I know. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. 2. And that's going to be x 10 times 1 over 5 is squared. That's the answer. All right, let's check the next one. Letter F, parentheses, 16x to the power 7, and this whole thing to the power 1 over 3. Again, we will be able to have applied this rule where the 16 is applied to 1 over 3 and x7 also apply to 1 over 3. This one is a bit tricky because look, cube root, let's write it here on the bottom, cube root of 16. 16 is not a perfect cube. And times cube root of x7. Cube root of x7. And we cannot simplify like 7 divided by 3. We cannot simplify because 7 is not divisible by 3. But let's break this down into a multiplication of a perfect cube, 8 times another number, and a multiplication of a perfect cube, x6 times x. Now we are able to make it simpler. Look, break down cube root of 8 times cube root of 2 times cube root of x6 times cube root of x. Okay? And we know the cube root of 8 is 2. We don't know the cube root of 2, so keep it. We actually know, but it's going to be a bunch of decimals, right? 6 divided by 3, x squared, and cube root of x. We can use product of radicals here, this property that you can put together if they have the radical have the same index. So let's write down here square root, cube root, I mean 2x, right? You can put together under the same root. And we can also multiply the 2 times the x squared. 2x squared cube root of 2x. That's the final answer. Okay, we need to practice. Basically, now we understand that if we have rational exponents, we can rewrite as a radical. What about if we have a rational exponent, but instead of 1 over n, we have m over n? What's the meaning of this? Well, what we will see is, since a to the power of 1 over n is equals to nth root of a, that is a to the power of m over n is the same thing as this whole thing to the power of m. And we can rewrite, we can write as a radical and a power. Another way is moving this power inside and am. Let's check some examples to understand. Again, write 4. Let me write big here. 4 to the power of 3 over 2. M is 3, n is 2. So the denominator we can write as a radical, is square root. And remember, if we don't have index, the index is 2. We don't need to write index 2. 4 to the power of the numerator, 3, is square root of 4. 2 to the power of 3 equals to 8. Next example, negative 8 to the power 4 over 3. And again, we don't have parentheses. The negative is not submitted to the power 4 over 3. It's like you can rewrite with the parentheses only on the 8s. 4 over 3, and this is negative. The index is the denominator, and the power is going to be the numerator. Cube root of 8 is 2, and 2 to the power of 4 is 2 times 2, 4, times 2, 8, times 2, 16. What about if we have an expression with x and numbers? Well, we can do the same thing. The denominator is the index, and the numerator is the power. We don't know the value of x. We cannot simplify this any further. Another thing to understand is the meaning of a to the power of negative m over n. Look, we know that a to the power of negative 1 is 1 over a. A to the power of m over n is the same thing as n root of a m. If we put these two together, or having a to the power of negative m over n, we have 1 over n root of a to the power of m. Examples. It's kind of clear, but we need to know how to apply it. Okay. That's the meaning of a to the power of negative m over n. 64 to the power of negative 2 over 3. Look, we will write 1 over 64, and then this exponent becomes positive. And that's going to be equals to 1 over, the denominator is the index, and the numerator is the power. You can write here or here. It doesn't matter. The final result will be the same. Okay. Another example. The negative is not submitted to the power, it's only the number 16. So negative. The exponent is negative, so let's rewrite 1 over 16, 5 over 4, power positive, 5 over 4 positive. So negative 1 over 4th root of 16, power 5. Look, we can simplify this, right? Because we know the cube root of 64 is 4. And 4 squared, 1 over 16. And we can simplify here as well. 4th root of 16 is 2 times 2, 4, times 2, 8, times 2, 16. To the power 5 equals 1 over 32. Okay, next, using the rules for exponents to simplify expressions. Remember those rules. If you don't remember, have a look at this table and the summary of exponent rules. You can write down in your notebook, or you don't need to memorize. But we will use those rules to simplify rational exponents. This will help a lot. Let's go to examples. If we have a multiplication and the factors have the same base, go back here. Multiplication with the same base, we add the power. So this is equals x 1 over 2 plus 1 over 3. Find the least common denominator between 2 and 3 is 6. And to make 6, we need to multiply times 3. Multiply times 3. To make 6 here, we need to multiply times 2. Multiply times 2. On the top, we will end up having 3 plus 2. That's x to the power 5 over 6. Next example, 1 over 4 squared times 1 over 4. Look, this is equals. It's kind of the same thing as the first one, but now we multiply, right? Multiplication of fractions, we multiply the numerators, multiply the denominators. 1 times 1 is 1. 4 squared times 4. Remember that there is an invisible index, or sorry, invisible power. 4 to the power of 1. Add the powers, equals 1 over 4, 3. And this is 1 over 4 times 4, 16 times 4, 64. And again, multiplication with the same base y to the power of negative 4 over 7 plus 6 over 7. This one is kind of easy because they have the same denominator. We can add or subtract. Keep the denominator, 7. Negative 4 plus 6. And this is y to the power of 2 over 7. A few more examples. Parentheses 32 to the power of 1 over 5 times x power of 2 over 3. This whole thing to the power of 3. Look, we will apply the power to each one of the factors, and the rule is that if you have the power rule for product and quotients, if you have a product to the inside the parentheses to a power n, then you can submit to the same power each one of the factors. That's what you're going to do here. This is 32 1 over 5 to the power of 3 times x 2 over 3 to the power of 3. And now for each one of the factors, we multiply the power. Let me see, we have a rule for that as well. That's the rule. Look, if you have a to the power of m and to the power of n, is the same thing as a to the power of m times n, right? What is 32 to the power of 1 over 5 times 3? Remember, this is 3 over 1. We can write as a 3 over 1. X to the power of 2 over 3 times 3 over 1. 1 times 3, let's right here on the bottom, 32, 3, 5, times x, 2 times 3, 6, 3 times 1, 3, 6, divided by 3. And keep simplifying if possible, because we know the fifth root of 32, this to the power of 3, and 6 divided by 3, x squared, right? 6 divided by 3, 2. Fifth root of 32 is 2 to the power of 3, 8. Final answer, 8x squared. I think understanding this first step is easy, but then you have to simplify and follow more steps. This can be a bit tricky. The simplification process sometimes can be a bit tricky. But the first step is quite straightforward. Just follow the exponent rules. Now the next example, I fix it, the example. Look, parentheses, -1 over 2 to the power 5, the whole thing is squared. The rule we will use is quotients, the power rule for quotients. If we have a fraction to the power of n, it's the same thing as numerator to the power of n over denominator to the power of n. First, let's check this sign. This sign is inside the parentheses. So this is going to be negative times negative, negative squared. Negative times negative is positive. And on top we have 1 squared. On the bottom we have 2 to the power 5 squared. Of course, 1 times 1 is 1. And 2 to the power 5 squared is 2 to the power of 10. Yeah, you don't need to evaluate. You're going to have a huge number. That's the final answer. Now we're going to use rational exponents to simplify radical expressions. Let's say we have those examples. Assume that all variables represent positive real numbers, so we don't need to worry about having a negative here. 8th root of x to the power 4. Let's rewrite this as rational exponents. The denominator will be the index, the numerator is the power, and we can simplify, right? Because we know that 4 over 8 is, yes, x to the power 1 over 2. And now we have square root of x. So this is, we can rewrite as a much simpler expression, that square root of x. Okay, next one. Say we have 6th root of 25. We kind of remember that 25 is 5 squared, right? So 6th root of 5 squared. Now we can do the same thing we did here. Rewrite as rational exponents, 2 over 6. Simplify, 1 over 3. And 5 to the power of 1 over 3 is cube root of 5. See, it's a much simpler expression. We have here 6th root of 25 is actually the same thing, equals to cube root of 5. Now use rational exponents to write as a single radical expression. We have two radicals, and we want to write everything under the same radical. Let's try to work this one out. X, the square root of x, we can rewrite as x to the power 1 over 2. 4th root of x, we write as x to the power 1 over 4. Now x, this is equals to x. The first rule, remember, multiplication of the same base, we add the powers, 1 over 2 plus 1 over 4. We have different denominators. The least common denominator is 4. This is equals x to the power of 2 over 4 plus 1 over 4. This is equals x power 3 over 4. And equals, under the same root, we have x. The denominator is the index, and the numerator is the power. That is the final answer. Now check the next example, letter B. Uh, the letter B, we have to think a little bit because we have different bases. Look, cube root of 5 times the square root of 2. What will be possible? Let's rewrite this as rational exponents. 1 over 3 times 2, 1 over 2. Actually, to have both under the same exponents, we need to have the same index, right? The index needs to be the same. And right now the indexes are different. That means the denominator are different. What's the least common denominator? Then you'll be able to have the same index. Yes, least common denominator, 6. So 2 times, then you have 6 times 3 times 3, we have 6. We can say this is 5 to the power of 2 over 6 times 2 to the power of 3 over 6. Now we have the same index. Look, since they have a common index, write down here the index, and we can write 5 squared times 2, the numerator is 3. That's the final answer. With that example, we finished section 7.2 about rational exponents. Now let's go to our challenge. What do you think? Move only 2 matches and find the greatest number possible. Well, yes, I can see a few options. Maybe you thought about this. Look, if we remove this stick and this stick, and we move to the first number, and then we will have one stick here, another stick here. That's 805. Yes, it is more than 508. But what about if instead we move this 2 sticks right up front, and then we can make a 1505, 1505, much greater. Wait a minute, there's another option. Instead of moving to the front, let's move to the back. And we have 5051, much greater number. And maybe we can think about more numbers, just moving these 2 sticks. But there's a thought, there's an idea. What about using our knowledge about exponents? And now we use the sticks as a power. So 505 to the power of 11. 505 to the power of 11. If you look into a calculator and find this number, you're going to see it's a huge number, maybe the greatest number possible. I'm not sure, maybe is the greater number possible. All right, just a thought, using our knowledge to solve this puzzle. Thank you for watching. Please answer the questions on MyLab Math to have full grade, full score for this lesson. And hope to see you again on the next meeting.